Hey everybody, and welcome to part 2 of our session of Builder series with Terry Lamb, co-founder of Nuts Finance. In this particular episode, he is going to walk you through Pike, the next generation cross-chain borrow-lend protocol. Terry, take it away.
Great. Thank you, Sam. Good to be back, and very excited to show you guys what we've been working on over the last 10 months for Pike. As Sam introduced, we believe Pike is the next generation cross-chain borrow-lend protocol. Mainly, if you have missed, the first interview session, strongly recommend you guys to go back and check it out, because in that session actually talked about all the problems that we are trying to solve with Pike. So not going to ramble on too much. Going to jump right into showing you guys Pike. And for today's session, actually, I'm going to walk you guys through a few key workflow that demonstrates the capability of Pike. The supply, borrow, repay, and on top of that, one piece of critical infrastructure that Pike relies heavily on, which is Circle's CCTP. Okay, so what you're looking at right now is actually Pike's dApp, and right off the bat, on the bottom right-hand corner, you can see this universal USDC pool feature. Now, what this feature is actually we have bundled the different native USDC across the various chains into one usable standard for our users, so that it makes the entire cross-chain borrow-lend workflow a lot more seamless and user-friendly. So throughout this demonstration, I will be highlighting how this universal USDC pool works. And ultimately, this function is powered by Circle CCTP. So let's get started. First off, I'm going to connect my wallet. Again, just a quick refresher. Pike is implementing a hub and spoke model. So what that means is the hub actually takes in all the accounting logics, and it actually validates whether the user has enough balance on the different networks, and it basically the message gets transferred between the hub network to the various spoke network in order to validate and approve these transactions. So in terms of the spoke, Pike is actually deployed on Ethereum, Optimism, Arbitrum, as well as Base. The reason why we're implementing this model is because we want to provide a truly native cross-chain experience for our users, so that they don't need to be wrapping their assets or bridging their assets to different chains. They could access Pike directly on their so-called home chain. What I'll do is on this screen, you can actually see on the supply side, you can actually see there's a CCTP tag right here, right next to the USDC. So as I mentioned a little bit earlier, what we've done is we've bundled the different native USDC across the different chains into one usable standard. Okay, in this case, it consists of Base, Arbitrum, Optimism, as well as Ethereum. Okay, the reason why we're able to do that is because these are all native USDC. In other words, they're official formats. So instead of having the users to deal with the different types of official USDC, we have bundled them all together so that users can actually access them as if they were one single unified standard. Now, to drive home the point that we're trying to make here, you can see that it actually displays our my current USDC balance, and this around 5,600 USDC. It's actually currently spread between my Arbitrum as well as my Optimism wallet. Okay, so the first thing that I would need to do, because Pike is currently on the testnet, the first thing that I'm going to need to do is to get some test tokens. So let's get some ETH. So what I'm going to do, I'm going to switch over to the Ethereum Goalie network. Okay. Now I've received 1 ETH. What I'm going to do is supply the 1 ETH so that I have collateral in order to borrow USDC from. So I'm going to supply the ETH. And just to remind everybody, the ETH here is a native asset. So it's a native ETH. It's not a wrapped version. It's not a bridge version. So that's why when we're conducting this transaction, we're actually doing it on the Ethereum network. Now, on the other hand, if let's say we were running the same supply workflow with the OP token, what would happen then correspondingly is we would be doing this, we would be supplying native OP token on the Optimism network. And this is one of the reasons why Pike is, again, operating on the, hub and spoke architecture. Okay, I have supplied the 1 ETH. So let's try to take out some USDC. You can see right now the borrowing cap is at around 1,500. Okay, I'm going to take out maybe 1,200. Okay, I'm going to spend a little bit of time to explain what this table here represents. So what you're seeing is, the gas fee as well as the transaction speed for various network where you have me as a user have the option to draw or borrow USDC from. Okay, and the last column here actually tells us that what is the current supply of USDC in these corresponding networks. Now, one thing that I want to highlight here is the Arbitrum network. You'll probably notice that the transaction time is relatively high compared to other layer 2 networks, and I will get into why that is the case. And also, you'll notice that there's a CCTP tag next to the supply. Okay, the 1,200 supply. Now, the thing that we've done here at Pike is, and this is again how we're leveraging CCTP, is when I want to borrow, let's say 1,200, originally on the Arbitrum network, there weren't sufficient USDC, for me to borrow. Now, what we've done is we have built a USDC pooling module where we can actively rebalance the USDC balance amongst the different network in order to facilitate, the user's borrowing demand. Okay, So what that means is, originally there weren't, enough liquidity. There weren't enough USDC liquidity within the Pike protocol to draw 1,200. But because we're able to use the CCTP function, what we're doing is we're rebalancing. So we're drawing USDC from other networks into Arbitrum just to facilitate this specific request. Okay. So what that means, right, for the end user is, the user doesn't need to go to the respective network, draw the USDC, and then if ultimately they want to use it on Arbitrum, they wouldn't need to then, send it again to Arbitrum. And this is, we believe, a very powerful feature as well as function of using CCTP. Okay. Now, keeping the demonstration simple, I'm going to. Oh, sorry. And because of that, this is one of the reasons why you see the transaction time to be higher. It's because there's actually, quite a lot of stuff that's happening. That's calling. The protocol is calling. So that's why, it affects the transaction time. Now, to make the demonstration relatively straightforward, let's pretend, we are going to borrow from the base network. So now I'm going to switch over to base and initiate this transaction. So we've built a transaction status counter just to give our users a peace of mind on the transaction status. I'm going to dismiss this. So dismissing doesn't mean I'm canceling the transaction. I can always come back to the screen. And you can actually see a progress update as well. Okay, and the transaction has been executed. So now I have successfully borrowed 1,200 USDC from the base network, and my balance has increased. Okay. So now I'm going to run through the repay workflow. So again, let's say I'm going to repay 1,000 USDC. And because I have USDC balance on different networks, these are all native USDC, I can then choose which one to repay from. Okay. Now remember, when I borrowed originally, I was borrowing the USDC from the base network. Okay. But because again, thanks to the official native format, the official format of native USDC as well as CCTP, what I'm going to do now is I'm going to actually repay this borrowing position with my balance on Arbitrum. So I'm going to switch from base network to Arbitrum and initiate the repayment. Okay, the transaction has been executed. And you can see that my debt position has actually decreased from 1,200 to 200 now. So what I've just covered are three main workflows to demonstrate Pike's cross-chain borrow-lend capabilities: supply, borrow, as well as repay. And all of this was conducted in a seamless fashion, in the sense that I didn't need to switch over to my wallet. I didn't need to go to my wallet to switch network. All of these switching is actually integrated, within the dApp itself. And what I've also demonstrated is the capability of CCTP. Two of them. The first one, bundling the different native USDC into a single standard where users can use them as, one unified USDC. And the second is the USDC pool module, where we are actively rebalancing the USDC balance on different networks just to provide the most seamless experience for the end user. So whenever, let's say there isn't a sufficient liquidity, USDC liquidity on a specific chain, the USDC pool rebalancing function will then call, using CCTP, call for the USDC liquidity from one chain to the other to fulfill, the user's request. So that's it for today. I hope you guys enjoy this product walkthrough. Thank you very much.